Hi friends, in this video we see how to solve problems related to star to delta conversion and delta to star network conversion. Right, the first question is find the equivalent resistance across A and B. So this A and B, for this across this A B we have to find the equivalent resistance. Right, you see this is, we cannot have a series and parallel configuration here. So first we have to make indent. So for that you see this is in star network fashion, right? Sorry, it is delta network fashion, this area, right? If I convert this into this format, what will happen? If I convert this into, this is delta, this I convert into delta and star network, then it is easy to solve the problem. Let us see how we are going to solve the problem. Fine. So first what we are going to have, we will take this only this area, this delta area. Fine. Whenever you have a problem like this in the like a bridge circuit, you take this delta area. So here you see this is 5 ohm, this is 3 ohm, this is 2 ohm. Fine. So I want to convert, get equivalent star. Equivalent star will be like this, right? Okay, this one will be equivalent star. Okay, so if I want this value, what I have to do? I have to multiply this one. Let us assume this is R1, R2, R3. So what is R1? R1 is multiplication of these two values. What are all the resistance which is coming and connected with this node? So it is 5 into 2 divided by total. 5 plus 3 plus 2, 10. So it is 1 ohm, right? Next I want R2. R2 means this junction, what are the resistance? This is R2. Here we have to see what are the resistance connected from delta. So here it is 5 and 3. Total is 10 ohm. So 1.5 ohm. Right? Total is, what is that? 5 plus 2, 7. 7 plus 3, 10. Next R3, this node. Because this is R3, this node, what are the resistance connecting? 2 and 3. So 2 into 3 divided by total. So 0.6. Now what I'm going to do, instead of this, you see this one I keep as it is. Instead of this area, this 5, 2 and 3, this delta, I am going to replace those 3 with this star network. What is that? R1. R1 is, it is like this, 1 ohm, and this is R2. R2 here 1.5 ohm, R3 is 0.6 ohm. Fine. Now bottom side I didn't make any changes, so this will be 1.5 ohm, this is 0.4 ohm. Rest of the thing will be as it is. So this is A, this is B. Now I can find equivalent resistance easily. What is the reason? You see this 0.75, this plus 1 are equivalent, RAB. These two are in series, 1.75, right? Next you see here current divides, here they are all, these two form a series resistance. So it is 1.5 plus 1.5, 3, and these two are forming series but parallel with this 3. So 0.6 plus 0.1, 1, 3 parallel 1. So 1.75 plus 3 into 1 divided by 3 plus 1, that will give RAB is equal to 2.5 ohm. Simple. Okay. So in this way we have to reduce bridge network into simple network. Then I can find equivalent resistance. Okay. Second problem, find the effective resistance between A and B. Again, this is the resistance. That is, they are asking equivalent resistance. So here you see, here also it is very difficult to find a series parallel configuration. But I have one chance. This is acting like a delta network. So I find equivalent star. What is the way? This is star. You put like this. This is one resistance. So here R1, R2, R3. So simply we can find R1. What is R1? I told just now only R1 means what are the resistance connecting with this terminal, R1 terminal? 20 and 20. So 20 and 20 divided by total resistance. This is 20, this is 20, 40, this is 60, 100. So it is 4 ohm. Okay. Similarly, you see what is R2. R2 is what are resistance connected to R2 terminal? This 20 and this 60. So 20 into 60 divided by 100, 12 ohm. R3 is what are resistance connected here? This 20 and this 60. So again that is also 12 ohm. 20 and 60. So it is also 12 ohm. Now I replace this delta into star network like R1 left hand side, R2 right hand side, R3 down. Right? So R1 left hand side, R1 is left hand side, that is 4 ohm. R2 right hand side 12 ohm, R3 12 ohm. Right? I didn't change anything. So here 18 ohm is there, that will be added in series. You see, after this blue, this 18 is coming. So it is 18 in series. Now it is easy to simplify. Again, you see, this I have made. After that, this 8 will be added. So this 8 I have to add. So this is 8. Now the circuit becomes very simple. Now what is my total resistance? RAB. This is AB. So RAB is equal to 4 ohm. These two fellows are parallel. This 12 plus 18, 30. 12 plus 8, 20. So 30 parallel 20. This is 30. These two are in series 20. So 4 ohm plus 30 parallel 20. That will give 4 plus 30 into 20 divided by 50. 600 by 50, 12. So it is 16 ohm. So RAB is 16 ohm. Okay. So two problems we are seeing for delta to star. Here we see what is star to delta, how the question may be. Here you see for the network shown in figure, find the equivalent distance. So here they have two star network in parallel connection, right? So let us see, first we can split this into two network. How? That's why I have drawn in a two different way. Yellow is one. This is one star. 5, 3, 4. This is another star. 6, 4, 8. 6, 4, 8. First I convert into delta network, then we can simplify. Let us see how we are going to do. So for this equivalent delta, I have to draw. So you see, you don't think it is star only. You can draw like this. So this arm I have drawn like this. 5, 3, 4. What is my equivalent delta? This is my equivalent delta. Fine. So I can draw like this. Okay, how can I find? Let us see. This is R1. This is R2. This is R3. What is R1? How can we find R1? R1 is first, whenever you are having a star, we have to multiply each combination first. So 5 into 3, then 3 into 4, plus then 4 into 5. Numerator will be same for all, right? Divided by, I want R1, right? So I want R1 means what is the resistor opposite to R1? 4. So divided by 4. So if you simplify, what you get is 7.75, right? So this is what 15, 12, 27. This is 20, 47. Numerator is 47. Next to R2, again numerator same only. We have to multiply individual combination. R2 means I want this. What is the resistance opposite to this? 3 ohm. So divided by 3. You will get 15.67 ohm. Next, R3 I want. Numerator again same, 47, right? What is the opposite? 5. So what do we get? It is 9.4. So now I got equivalent star network or pi network. How can I draw? This implies star R1 is 11.75, 11.75 ohm. This star I draw like this, no problem. Fine. This will be 15.67 ohm. This R3 I draw like this. This will be 9.4 ohm. Okay. Right. Now I take this one 648. So 648 I take 648. Now can we draw? So as usual we have to find what is the equivalent network. This is R1, R2, R3. This one I have to find. So if I want to find this one, what I have to do? First, what we have to do? Let us assume this is R1. R1 is first individual component multiply 6 into 8 plus I compare this section 8 into 4 plus 4 into 6. Right? Divided by I want this one. What is opposite to this one? Opposite to this one is 8 ohm. Right? So what we get is 13 ohm. Otherwise you draw like this, no problem. Like our previous problem, left hand side you see, so draw the same thing 534 instead of 534 648, right? Follow the same procedure. I am following the same procedure, just draw like this. R2 is numerator is same 48 plus 32 50 80 plus 24 104. 104 divided by R2 is what? R2 is nothing but what I kept R2 is left hand side. R2 is left hand side. So this is my R2. Right? So if I want this one, what is opposite to R2? 4. Right? Opposite to R2 is, this is the R2 side. Opposite to that is 4. Right? So if I want this side, divide by that side, opposite side. So 4. 104 by 4. That is 26 ohm. R3 is, numerator is 104. R3 right hand side, opposite 6. Simple. Right? 17.3 ohm. Right? So please understand, very simple. When you want to convert a star to delta, what you have to do? Make individual combination multiplied, then divided by opposite. 8. First I want this one. Equivalent pi means this area multiply by this. Next I want this side divided by, sorry, not multiply by, divided by. So first I want this one R1 divided by 8. Then I want this one, sorry, R2 will be this side. So divided by opposite side. So divided by R2 I want, where R2, where is my R2? This is my R2. So this is my R2. So multiply by opposite side. Opposite side is 4. This is R3. So multiply by opposite side 6. Okay. So in this way we can find the answer. So R1 is 13 ohm. R1 is 13 ohm, we can find, and then R2 is R2 is 26, R3 is 17.3. R2 is 26, R3 is 17.3. Now we got both networks. This is first network, this is second network, both are parallel now. So if I combine both the networks, the circuit will be like this. It's coming like this, right? So this R1 is 13 ohm. This R1 is 13, this R1 is 11.75. So this is 13 second, that is top side is 13 ohm. This is 11.75. Next to left hand side, what we got? We have 2. Right, similar right hand side also we have simplified. Left hand side R2, R2, right hand side R2, R2. So left hand side we got 15.67, here 26 ohm. This only we have to find. Similarly, this R3 is 10 ohm. This R3 is 17.3 ohm. Fine. Okay. So is there anything? Okay. This one, you see what are the things we have? This is 17.3. This is 17.3. This R3. This R3 is 9.4. right? Is there any load? 9.4, right? Here we have 110 ohm. So these two I have reduced. So this is 9.4. First one right hand side is 9.4. Second one right hand side is 17.3. So 9.4. Sorry, first one is 9.4. So I change it. 9.4. This is 17.3. Finally load 10 ohm. Now it can be easily simplified. Why? You see, these two are parallel. These two are parallel. These two are parallel. Right? So how can I simplify? 1 by R equivalent is equal to, sorry, first R equivalent, how can I find? This is 1 by 9.4, this area, plus 1 by 17.3, plus 1 by 10. If you simplify, 3.78 ohm, right? Next, this 13 and 17.5. This 13 and 7. This is 1, this is 2, this is 3. 13 and 17.5 are equivalent is 13 into 17.5 divided by 13 plus 17.5. If you get 6.17 ohm. Next, 3, 20 and 26 and 15.767. So R equivalent is 26 and 15.67. 26 plus 15.67. It will give 9.78 ohm. Fine. Okay.
So everything we got. Now this is what left hand side. Left hand side is 9.78 ohm. This is top side 6.17 ohm. This is right hand side 3.78 ohm. Right hand side is 3.78 ohm. So they ask equivalent distance in this side. We have to see from here. So if you see again, you see these two are in series with 9.78. So RAB, if I say it is A, equivalent distance A between A and B is 9.78 parallel 6.17 plus 3.78 is 9.95. So 9.78 into 9.95 divided by 9.78 plus 9.95, what you get is 4.93 ohm. This is what equivalent resistance. So in this way, star and delta network can be used to reduce the complex circuit into simple circuit. I hope you understand all the three problems. If you have any doubt, please ask me in comment section. I will clarify. Thank you.